Assalamu alaikum wa rahmatullah. Welcome everyone to IE 203 Introduction to Industrial Engineering. And in this course, we will go over the industrial engineering discipline and all the major areas that we covered here in the industrial engineering department. And we will learn at each area some techniques and tools and methods that related to that area. We will start here in this session with the beginning and development of industrial engineering and the history of the industrial engineering. We'll see also the major areas and also the organizations, the authentic organizations related to this discipline. Before we start with the definition of industrial engineering, since it's engineering at the end, we have to go back from the beginning, where was started and where the beginning of engineering, and then where the industrial engineering came from after the development of the field of engineering in general. The engineering and science, they come always close to each other. Engineering is considered to be base of science, but in terms of the application is different. So there is always a comparison between them and they are always related to each other. The science is considered the search of basic knowledge. What is the engineering considered to be the application of this knowledge? They search for the reason why things fall down when you leave them due to the gravity. They study the gravity. They study how the energy transferred from one to other in terms of the physics concept, the magnetism and the electricity. The physics, math, they go behind how this nature things and how this basic knowledge is being found. They explore more about the characteristics of, for example, the material, the difference between them, how they are affected to other factors and elements. The engineers work on the application of this science to solve real problems. But they have in similarity, as we just talked now. Engineers solve problems. When you do math and you have taken calculus and taking math courses, you do solve problems. So mathematics, or the mathematicians اللي هو الرياضيات المختصين في الرياضيات, and the engineers, they do solve problems. The engineers analyze, and the same for the physics. If you think about it, also in the statistics, who are part of the mathematics, the statistics analyze data and provide, for example, the mean, the standard deviation, the variance that we have covered in probability and statistics. Also, the economists, they do analyze. They analyze the market, they analyze budgets, they forecast also. So this is also a job not only the engineers do here. Engineers, they are unique in terms of the designing function. In top of all the things that we have said, the engineers are mainly design systems, design product. You as an industrial engineer, you would see also here in today's session that even the service processes or the service transactions can be designed by an engineers. So the distinguished characteristics of engineering considered with the design system. Designing systems or designing a product, whether you go all the way to complex system or you just design a product or a process or as we said, service, that will be the main characteristic in terms of the engineering. But since we are talking here about engineering in general, so we are talking about systems in general. The design needs creativity. لازم يكون عندك حس إبداعي. You as an engineer, you are not a regular problem solver. You just follow book and steps to solve problems. You should have creativity. In top of solving problems, you should have creativity. So when you are going to solve sometimes some problems, it requires from you to design something new. And here it comes your creativity need in implementing in the field of engineering. In addition to the creativity, you need, or this comes by the time, the experience. The design is an art, and as an artist, by the experience, your designing skills would be improved based on the things you have solved and resolved and designed previously. So this skill will get improved over the time. And sometimes here the creativity, if it's something that outstanding, it will make up the experience. Yani we see some gifted students and gifted engineers, and those students or engineers, they are creative in a way. They could come up with innovative products that it doesn't need the experience in this time, and it could exceed the need of the experience. And we have seen this many times in innovative products, even in our current time. The software or Internet of Things, now we have seen like those, for example, the beginning of WhatsApp application, Instagram, Facebook. We have seen some young people, they started those applications, and now they become leading in terms of the technology and social media applications. The creativity, it needs sometimes time to be built up, or sometimes it becomes as a nature, but the experience, definitely it will need time until it built up. That's why the engineers, when they graduate, the amount of time they spend in the field, that will increase their value in the market need. Okay, so you have to be patient when you just fresh graduate from your program, and wait until you've been exposed to many applications, until your experience will build up, and then at the same time your creativity inshallah also will build up with it. Moving on to the engineering process. The engineering process, this is very general. You cannot just say this is, I'm going with that to solve any problem, but to show you how the logical thinking and periodic thinking on solving problems using engineering concept, starting by finding the problem or the need or the potential where you need to solve a problem. Symptom هنا العوارض، إيش الظاهر أو العارض need there I need to solve it or search and find it. Then you establish the outcome desired or the desired outcomes، اللي هو طيب أنا عندي المشكلة، إيش النتيجة المتوقعة إنه when I solve it, what is the expectation here when I solve it? Should I'm going to reduce time? I'm increasing efficiency? I'm designing a new product that is more reliable? يعني what will be the outcome? Then you do analysis and experimentation, and then you come with alternative solutions. Please pay attention to this, and you see it becomes as a loop here. So you come to solutions, alternatives, and then you go back and do experimenting, analyzing. This loop here, it needs time and it needs an effort from you. When you come to the level and take a capstone design, or you design at any course where it requires designing project, a project needs a design element, it can't be just the one solution that you provide and consider to be the only solution over and exist there to solve this problem. Always engineers search for alternatives. Think about it from the basic products you are using daily, your phone, your car. Those they have experienced and analyzed and competing with other designs alternatives until the company and the stakeholders related to that finalizing the design of that product you are using now. Cars, you can see how many times they come up with sketch and expected designs. Those designs, they go then and analyzed by engineers also to see how the applicability to use this design and consider the aerodynamic of the car, the fuel consumptions, the power, and all the related features to that car. They do adjustments and then they come up with another design. They may get rid of that design because it is not useful. The same for phones and for softwares. The interface you see in your application or your phone, there's been some engineers behind it. They've gone in this, or they spend time in this loop here by providing alternatives, analyze them, experiment them, and then they go to one alternative selection and implement it as a solution. But as an engineer is not just to go to the problem and just provide one solution and say, here is my solution. So usually you expect when you work in a capstone design project to provide alternative solutions for your problem and compare between them and show the criteria why you selected, let's say, solution A instead of B, or alternative A instead of B. And that needs an analysis and experimentation to do so. So this is the engineering process. The early development of engineering, before we start with the industrial, it was based on the physics phenomena, like what we could recall Newton, the gravity, and overcoming frictions, lifting, constructions. These are the engineering applications from the physical phenomena that they have found. So the airplanes started to be designed, and the buildings, they start to be constructed or designed based on physical phenomena by understanding the static principles, the force, the dynamic material. So that was the beginning. It was based on physical phenomena, and that was in before the year 1800. After that time, development were concerned with the chemical and molecular phenomena اللي هو الأشياء الكيميائية والجزيئات, like electricity applications, property of materials, thermal processes, and other chemical processes. Here it was more of static and construction based on physical principles. Later, the chemical and the molecule, like electricity and thermal, they become more explored by scientists, and then the engineers they use those in terms of the application in solving problems. In 1750s, that was the beginning of the first engineering school, and it was established in France. So this was the beginning of the first engineering school. Imagine, 1750. Now we are giving this lecture in 2021. So you see how the engineering field is old, and this career, it's been there a long time ago to develop this and provide this civilization. We see it in the countries. The term of civil engineering was first used in this year exactly. And as a matter of fact, Civil engineering was the first engineering discipline started, and later, after that, the chemical engineering and all the branches, you will see how they are related to each other. But the first engineering discipline was established in this year, and it was the civil engineering. Principles of early engineering were first taught in the military academics. So the teaching and the application was mostly or heavily used that time في الاستخدامات العسكرية والمعاهد أو الأكاديميات العسكرية to build roads, bridge construction, and that they call it also military engineering, but it was a civil, as we see it now, it's a civil engineering. And then it become not only in the military, so they abstracted to more or larger scale, and they call it the civil engineering. But even when we say the military here, the application were civil, is not really and military, like when we talk here about developing weapons and missiles and so on. So that was the beginning of the engineering field in general. Where was the industrial, and when the industrial came? Actually, the industrial considered to be late in terms of the development compared to the other engineering fields like civil, electrical, mechanical, and we will see in the next slide how is the development of the industrial engineering came late, but doesn't mean that you, as an industrial engineer, your field become late in terms of the foundation. That's mean is not useful as them and the other majors. No, you will see how it is unique in terms of the development, and the same as it is relaying and inherited from the other engineering disciplines. The engineering founder, let's say we can say, and we call him the pioneer of industrial engineering, was Frederick Tyler. Frederick Tyler, he is the one that considered to be founder or the beginner or the developer of the industrial engineering, and he started to consider designing the job for maximum efficiency, what we call it now utilization of your employee in the job floor, for example, reducing time, which is now we consider it in the new concept and application, the lean, analyze, improve method of performing the work, as you will cover it in the work studies and operations engineering, set standards for what the time should be, and that exactly when we come to also the quality control and standardize the processes. So that was when in 1856 to 1915. This is after World War II. So we can say the establishment or the real establishment of industrial engineering was really after World War II. And that time, the countries who involved in the World War, they consumed the resources and many losses happened. So they start in thinking, building their countries in a different concept and different way that will reduce the time and reduce the waste that needed to recoup again from that war. And that's why the industrial engineering came in that specific time where it was a need and an essential compared to the founding of the other majors of engineering, where it was found prior to this time, and the need for them and the application for them were different in terms of the need that time. Here it was Charles, he's the mathematical or mathematics professor, developing the learning curve and the division of tasks, and you start to systemize the process and the operations. This is before the industrial engineering, but they consider, even though he was a professor in mathematics, he started to give this concept of having a process and operations, and understanding what is the waste, resources, and so on. But the application didn't come heavily as much as it was here in the 1856 and to 1950 by Frederick Tyler. The relationship of industrial engineering, this figure, I like it in a way that visualizes the concept when we talk about how is the industrial engineering related to other fields, and how it was inherited and it becomes from the other majors in the engineering. As we see, the logic and mathematics was the beginning. We can say also the physics, also and science were the beginning, as we explained earlier. And that led to a military engineering, which was exactly a civil engineering that time. And the civil engineering branched the mechanical engineering, and you see how is the physics has two branches. That's why when you study physics, you have most of the engineering programs, they do have two levels of physics. One related to static and dynamics, and that's related to the mechanical engineering. And nowadays also civil engineering use that heavily, but during the beginning of the time when the civil engineering was started from the beginning, it used it somehow, but not as we do now, and how the complexity of the civil engineering become. And the second part of the physics that you always take, which is the electricity physics, اللي هو المغناطيسية والكهربائية, and that is related to the electrical engineering. So the mathematics and science, always the foundation and the basic science needed for all engineers, regardless of your major. You need the physics and math, and that's why you study them before you enter any engineering program, because they are the core knowledge, and the engineering is using this core knowledge to solve current and existing problems. Okay, from the electrical engineering, we have seen computer information science, controlling اللي هو automatic control, and so on. There are others, communication, electronics, power, all that also comes from the electrical engineering discipline. In the mathematics, we have also some branches that come in modern time and in later time after the beginning of the mathematics. Statistics, which is a core knowledge for industrial engineering, as we will see. And from statistics, we have quality and reliability, we have operations research, probability. Also, it's another field, maybe if not here, but it's part of the mathematics. And the mathematics integrate with the electrical engineering in terms of the computer information science, because they use both mathematics and electrical concepts and computer concepts. And let's go down here in the civil, where we stopped with the mechanical engineering. And from the mechanical engineering, there were many branches comes. Even now, the civil engineering, it has many other disciplines like environmental, construction, water resources, but doesn't mean that those were not related to the big umbrella of the civil engineering as well as those disciplines. This is just to show you how the engineering development become, and the industrial engineering history also, and visualize this picture in general, so you can link the things together. After the mechanical engineering was exactly the first step or the initial step in terms of the development of industrial engineering. And that they call it the early industrial engineering time. From the mechanical engineering also, there was a major branch also related to the industrial engineering, and was the manufacturing engineering. As you can see, it became from the industrial engineering, which was also a branch from the mechanical engineering, and it's a branch also from the mechanical engineering itself. They call it the manufacturing. And why now it become manufacturing? Because remember, the industrial engineering came when? After the World War II. Now countries, they, as I told you, they redesign the way how they develop their countries. Now manufacturing becomes more, there was more demand for manufacturing to build up their countries and build up their resources again that consumed by the war. So the manufacturing now was heavily used and needed, and it became that time was the future, which actually the manufacturing until now, even with the different concept of manufacturing, how it's improved, but it's a major element for any country economy. The mechanical engineering with the chemical engineering, which was formed from, if you remember, the molecule and the chemistry, the chemical engineering come between the mechanical and the chemistry. And we see now petroleum and اللي هو الرياكتورز اللي هو الثيرمال انجينيرنج، المهندسين اللي بيشتغلوا في الاشياء المحطات الحراريه ولا المفاعلات الحراريه الكيميائيه. So here is the application from them, and from here the born of the industrial and systems engineering that we see it today. As you can see, it's an integration and development of many fields, beginning from the mechanical engineering and manufacturing, also considering the process and production engineering. The same time, the management philosophy, psychology and sociology اللي هو علوم الاجتماعيات والعلوم النفسية والعلوم الإدارية, they were feeding the early industrial engineering field, and then they are integrated with the industrial engineering to an industrial and systems engineering. This is from this side. From here, the statistics, operations research, the control theory, computer information science, as well as from physiology اللي هو علم الوظائف والأعضاء, the ergonomics اللي هو human factor, we call it economics, الاقتصاد, they were also input to the industrial and systems engineering. So basically, that was the reason why the industrial system, the new state of the industrial engineering, become late compared to those major engineering disciplines. They call them the major four engineering areas, اللي هو civil engineering, mechanical, electrical, and chemical. Become late because used many of their applications as core knowledge for the industrial and systems engineering. The industrial and systems engineering also, there is a unique thing about it. It didn't start from the physics and math as a start point, although all the engineers, as we say, they are based on physics and math. But you see, here is the transformation when it comes, and in considering the management philosophy and psychology, productivity science, علوم الإنتاج, الفسيولوجي, علوم وظائف الأعضاء. This was not related to the physics and math. They were independent core knowledge. They are from different fields than the physics and math, especially when we talk management, يعني management and physiology, sociology, psychology also. Those are not math and physics. Okay, so what we are trying to say here, we are saying the industrial systems engineering, the unique about it, starts from the market needs and then used the application or use the other engineering branches to solve the current or existing needs. In other words, the needs becomes more complex. مع الوقت الاحتياجات في حل المشكلات أصبح معقد. They were not just a physics problem and mathematics problem or physics application or mathematical application. And this is, by the way, applied to the all engineer. To be honest, in these days, in the current days and in the future, you are not going to solve existing problem with the same exact technique from the foundation of the, let's say, the electrical, civil, and mechanical. Nowadays, the problems are more complex. When we come to a manufacturing or service, things are more integrated with each other. Software application integrated with the service transaction. بتروح لبنك، البنك متعامل مع system application software enterprise system. When you go to manufacturing, there is an automation, and this automation needs control. There are mass of human interaction and machine interaction. And here also, when we come to that point, a psychology part, a sociology science, it's needed. The people and the human, they are not like the machine. The machine are consistent in the delivery. The human, they are affected by many factors that they change their performance. Taking an example, if I put you in a stress or I put you in extra work, your performance would be different than if you didn't have these factors. The variation between one human to another also, this is another factor. Those are not from physics and science and math. Ergonomics, economics, those also are different fields that need different studies. That's why the industrial systems engineering use these scientific disciplines and engineering disciplines to solve a more complex problem using existing solutions from all these disciplines and follow the logic and order of engineering process. So this is a unique about the industrial engineering. It's integrated with many other fields and many other scientific disciplines. Okay, so what is the definition of industrial engineering first, before we come to the systems? Is concerned with the design, improvement, and installation of integrated systems. Who are the integrated systems? Integrated systems of people, material, information, equipment, and energy. You see how many things are related to each other. Each of those, they need a discipline to be handled. البيبل عندنا HR وعندنا management وعندنا business وعندنا psychology, sociology, science to deal with them. Material, we have mechanical, we have material science. Information, we have mathematics, we have computer science also. Equipments, electrical, mechanical, energy, the same thing. So imagine you are dealing with these integrated systems to design them, improve them, and install them. It draws يعني بيرسم الحل أو بيحل upon specialized knowledge and skill in the mathematical. So you are using mathematics, physics, social science together مع بعض بتكون. So don't think the industrial engineering is only business or social science. You never be away from those two if you are an engineer. You need to be mastering basic science to be an engineer, regardless of the major you are entering. And remember the creativity part and the experience part we have talked earlier in the slides. You need those with the principles and methods of engineering analysis and design. What do you mean by methods of engineering analysis and design? Remember the process, how the engineer do solve the problem. Recall defining the problem and evaluate or establish the outcome you are planning to do, and then analyzing, do the iteration of the alternative designs, and so on, that we have already explained. Predict and evaluate the results to be obtained from such systems. So you are focused at the end to the results come from such system after you use these scientific methods and science and applications to solve the problem or design or improve or install of integrated system. IE role in service industry, as we saw that the manufacturing took a big portion in the beginning of the industrial engineering. If we just recall here to this picture, here was the beginning, and most of, or the heavy use was for the manufacturing. But when it becomes to this recent formation, and they call it the industrial, the modern industrial engineering or industrial systems engineering, more things integrated to have or to provide the capability of industrial engineering to deal also with the service industry. In the early days of the industrial engineering, the application after the World War II, as we said, was fully for manufacturing. After that, IE were also applicable in non-manufacturing environments. Actually, thousands of industrial engineers are employed by government organizations to increase efficiency, reduce paperwork, design computerized management, control systems, implement project management techniques, monitor the quality and reliability of vendor supplied purchases, for many other functions. And we can see from this picture here that the diversity of industrial engineering, we can see it in different applications, from minister, from a CEO company of Apple here, or technological or communication, also a power companies like here, an entrepreneur and a founder for breakfast restaurant, a founder or father of Toyota Production, the well-known name in manufacturing after World War II, a president of a country, many others. There are many names. These are just to have a sample. Now, how become the industrial engineering moving from manufacturing to other or non-manufacturing like service industry and others? Like here in industrial engineering, it's a diverse discipline and concerned with design, improvement, installation, and management. As we said, of this definition, we already covered it. So therefore, the industrial engineers can employed in almost any type of industry, business, or institution, from retail establishment to manufacturing plants to government office to hospitals. So you as an industrial engineer, you fit anywhere, everywhere. مستشفيات، وزارة صحة، بنك، وزارة اقتصاد، تخطيط، مصنع، مدرسة، جامعة، مطعم، business، معهد, anywhere you can fit. And that's the unique and open opportunities to graduates from this field to have more job opportunity compared to others. Okay, so moving on to the modern name of industrial engineering, which is the industrial and systems engineering. System engineering itself is very similar and close to the industrial engineering. It deals with the same thing, and we will see them also hand to hand after this slide. It's a methodological اللي هو method based discipline approach for the design, realization, technical management, operations, and retirement of a system. A system, وإيش السيستم هنا في systems engineering, is construct or collection of different elements that together produce results not obtainable by the elements alone. So they have to be all together. And here is the difference. The industrial engineer deal with each one of those in the system. In the systems engineering, they develop the system based on those elements. The elements or parts can include people, hardware, software, facilities, policies, and documents. That's all things required to produce system results. So here is a key word: produce system results, and there you work to provide you work on the system itself to obtain from that system the improvement you would like to. So when we put the industrial and systems engineering definitions next to each other, we see many common between them, and that's why the ease of integration between these two was very easy and very useful in terms of the application. The systems engineers design and optimize complex system. They work with an array or يعني مصفوفات or other technology professionals, including hardware engineers and program engineer, as we can see also software here engineers. In the industrial engineering, on the other hand, manage and improve manufacturing processes and service operations. The industrial engineer primarily concerned with finding ways to better utilize machine, employee, and additional assets that impact operation. So obtained from some such systems means that how to improve, utilize, and manage this such system. Here, how to design a complex and produce the system itself. So here producing and here improving. So when you integrate them together, basically you see them both, they use almost the same elements of human, of people, methods. They deal with different aspects in the system. So the integration was essential to have them all together, and that's, they call it, the modern name of industrial engineering is the industrial and systems engineering, which acronym or the abbreviation IISE, where industrial engineering only IE, but most of the industrial engineering we are seeing these days in all universities, schools, they are somehow industrial and systems. You cannot teach the industrial now as it was founded in the era of Frederick Taylor. Now the demand in the market is different. It needs or it carries complexity more, so it needs the awareness and the application of both of them. Regardless of your major certificate is industrial and systems or industrial engineering, within the curriculum and the description, you can tell that you are working on a modern industrial engineering discipline. The IISE designs systems at two levels: human activity level and management control level. The first level is the human activity level, is concerned with the physical workplace and human activity occurs. So all the things related to the soft side from the human activities. The second level is the management control level. is concerned with the procedure, planning, measuring, controlling all the activities within the organization, whether technical or complex, like software, machines, material, or a soft like documents, process, and so on. Okay. The IISE body of knowledge here is very, it shows you how now you are working or studying in the modern industrial engineering, because the body of knowledge, most of them, you are covering them here in this major in the Department of Industrial Engineering. And we will go over some of those in this course as a basic, but in some of them you will explore them more in details in future courses, starting with the work design and measurement. And I believe you are taking, or you are going to take, work studies, which is related to this body of knowledge, operations, research, and analysis. And there are 2 courses related to this body of knowledge. Engineering economic analysis, by this time also you should have either taken, or you have taken, or you are going to take economic or engineering economy. Facility engineering, and this is also will be covered. Quality and reliability, there is a quality control course covering that. Ergonomics, human factor, there is a course called ergonomics that you will cover this body of knowledge. Operations engineering and management, and there are the engineering management course that covered this part. Supply chain, also there is a course and comes in the senior level, covers the supply chain. Engineering management, 7 and 9, they are sometimes overlapping. You do here engineering management, there is a course operation planning and control also works here, and there. Safety, this is partially covered in the ergonomics and engineering design, and there is an elective course for the safety. Information engineering, and this is very general, you cover it through all the courses of the engineering. Design manufacturing, you have manufacturing processes, and that covered this part. Product design development, you do that also in the computer aided design course. System design and engineering, you do here this course, systems engineering, and also the simulation engineering course. So these are the IISE body of knowledge, and as you can see, all of them, you are covering them in the major of industrial engineering here in this department and the Bachelor of Science program. You have maybe you are taking some of those now, you are going to take them next year. So these are the body of knowledge of IISE. The professional organizations that you need to be aware of, and you explore them, you follow them. If you could also subscribe and acquire the membership with them if you can, because it will keep you updated or up to date in your discipline. The first one, Institute of Industrial and Systems Engineers, IISE. The old name of that one was IIE. After the integration, which was just recent, by the way, the name, a couple of years ago, maybe 2 or 3 years, the integration between those 2 names, and the organization changed their name and updated to IISE. Institute for Operations Research and Management Science informs. American Society for Quality, ASQ. American Production and Inventory Control Society, APICS. Society of Manufacturing Engineers, SME. Society for Decision Science, Society of American Value Engineers, American Association of Cost Engineering. Those all related to the body of knowledge of industrial engineering, like for example, here to the quality itself only, here to the management science, here to and the operations research and the management, here in the manufacturing. Here you can find in the body of knowledge, as we said, it came from different disciplines and engineering fields. So you can see mechanical also subscribe here, manufacturing engineers, production engineers, also industrial and systems engineers, if they are interested in this. But the major umbrella for industrial and systems engineering is the first one here, Institute of Industrial and Systems Engineers, the IISE. For the local organization in Saudi Arabia, we have Saudi Society for System Industrial Engineering, SSIE. I believe triple S here. I will fix the name in the shared slides. So SSIE, Saudi Society for Systems Industrial Engineering, triple S, not double S, IE. You can search with the full name, not the acronym or the abbreviation. As Saudi Quality Council, SQC, I believe. This also a local organization where you can search and find updated knowledge regarding to your discipline or your body of knowledge that you are interested on, because some of you, maybe he is interested in one or two body of knowledge and he would like to continue his education or learning and doing masters or taking extra trainings and maybe also acquiring for job related to that body of knowledge. But you need to be aware with all of those areas or body of knowledge, because the IISE or the industrial engineering cannot be taken apart and you say, okay, I just want to focus on one or two of those. As a major in Bachelor of Science, you have to cover them all. Then in future trainings and extra programs or graduate programs, you can choose between them. The IE or the IISE, you can name it for this course that we are going to cover. We are going to cover 5 major areas. Underneath each one of them has more than one body of knowledge from the one we have talking about before. We will cover operations engineering, manufacturing systems, human factors and safety, quality and reliability, engineering systems management. We will cover them in the in this course in separate or independent modules. So each module or each sessions or group of sessions will cover one of those areas. Under each of those areas, you will cover the body of knowledge that related to it, and we have it in this way so you can map it to your IE program and it will fit the courses that you are going to cover in this program. I hope you enjoyed this session and you get information and be updated about how was the history of the industrial engineering, what are the body of knowledge, when was the beginning of the industrial engineering, how it was integrated or it was discovered or developed from different engineering disciplines and science applications or science also areas. Also, we have covered the integration between industrial and systems engineering and how they are related to each other, and the small difference and the slight difference that distinguish them between each other. Also, from the beginning, how the engineering was found from the beginning, and what is the difference between engineering and science, where was and when was the first engineering school. So all these, we'll cover it in this session. I hope you enjoyed and learned from today's session. I will see you in next session when we start talking in more details about each of those areas, which you will cover them eventually in the program with specialized courses that will give you details and more depth about each one of them. See you and wish you all the best.